This is Chapter 3, Section 4. We're looking at sketching polynomial graphs. Now, in general terms, they will have the same number of directions as the biggest power. So if you have a fourth power, it'll have 4 directions, third power, second power, things like that. If the largest power is positive, the right side goes up. If it's negative, the right side goes down. So in this case, if you have an x to the fourth, it's going to have 4 directions. If it starts with a positive, it means the right side goes up. So we have a right side going up, so it's going to go up. Then we have going up, that's one direction. And then it just keeps wiggling back through, so we have 1, 2, 3, 4 directions. Okay, in this case, we're going to have 6 directions, and a negative means the right side goes down. So the right has to go down, and then we have, again, we just count and keep putting directions until you have 6 of them. So it's going to look like that. This last one, x to the fifth, it's going to have 5 directions. Starts with a positive, so the right side goes up. So our right goes up, and then we have 5 directions. So it's going to turn around until you have 5 different directions. 1, 2, 3, 4, 5. Just count them. Okay, now specifically, if you have a factored polynomial, it gets more complicated. If you have a square, it's going to look like a parabola, which is U-shaped. If it just has a first power, it's going to have a line, which is linear. Third power are cubic, and if cubic functions go down and flatten out. So we have x squared, x minus 3 cubed, and x plus 4 to the first. First you find the zeros. There's nothing next to x, so that's 0. The minus 3 means you have a positive 3, and a plus 4 means you have a negative 4. You take the opposite of those numbers, and I put those on a number line. 3, 0, and negative 4. Then I go back, and 3 is going to be a cube, so it should be flat. 0 was our square, so it should be a parabola. And negative 4 should have a line going through it. Now at the very, very front, it's positive, which means the right side's going to go up. So we're going to go up. Now this has to be a flat spot because it's a cube, so it's going to have to flatten out and go down. And then this has to be a parabola. Well, you just turn around and make it into a parabola. And then this has to have a line going through it. Well, you just turn around and make a line going through it. And that's what the curve's going to look like. Okay, zeros and bounds. A function is a 0 between any two numbers if the sign changes when you plug the numbers in. So if it goes from a positive to a negative, it has to go through 0, essentially. Okay, the question says between 1 and 2, so just plug in 1. Gives you 1 cubed minus 2 plus 3. That's a positive 2. If you plug in 2, 2 cubed is 8, minus 4 plus 3 makes 7. There's no sign change. It didn't go from a positive to a negative, or a negative to a positive, so it doesn't go through 0. So it's not 1. Okay, and the final thing is a bound. Positive numbers abound if, when you use synthetic division, all of the numbers turn out to be positive. Well, if you take this same polynomial and find out, is 3 a bound? Are there any numbers bigger than 3? You do a synthetic division. 1, 3 gives you 9, minus 1 is 8, and 3 is 24. That last one should be 25. They're all positive, so yes, it is a bound. Or no, there are no zeros greater than 3. So yes, that is a bound, which means there aren't any